Good morning, everyone. Welcome to the Civil Engineering Materials Laboratory. Today, we are going to perform the tensile test using the Universal Testing Machine.
Good morning, sir.
This experiment is conducted according to IS 1608-2022.
So we must follow every step exactly as mentioned the standard?
Exactly. Following it ensures accurate results. Our objective today is to determine the yield strength, ultimate tensile strength of the steel specimen. These properties are important for structural design, aren't they? Absolutely, and durable structures. Every bridge, building, and steel structure depends on the strength of its materials. So this test helps engineers choose the right material? Exactly. Material testing is the first step towards safe construction. This is the standard mild steel tensile specimen used for today's experiment. Why is the middle portion thinner than the ends? That section is called the gate, where deformation takes place during the test. This is the Universal Testing Machine, commonly called the UTM. Can this machine perform both tensile and compression? Yes. It can perform many different material tests with high accuracy. Safety comes first. Never stand close to the machine while it is operating. Yes, sir. We will always maintain a safe distance.
Before testing, we must measure the original diameter of the specimen. I am measuring it carefully using the vernier caliper. Good. Accurate measurements are essential.
Record the original diameter and gauge length in the observation sheet.
The measurements have been recorded accurately, sir.
Excellent, just as important as the experiment itself. Now place the specimen carefully between the upper and lower grips.
Is the alignment correct, sir?
Yes, perfectly aligned. Now tighten the grips firmly before starting the test. The specimen is properly aligned. Now tighten both grips firmly so it does not slip during the test.
The specimen is secured, sir.
Excellent. A secure grip ensures accurate test results.
Now we set the correct loading rate according to the testing standard. Everything is ready on the control panel, sir. Very good. Never start the machine without checking these settings.
Before we begin, let's check the alignment one more time.
Everything looks perfectly aligned, sir.
Good. A final inspection prevents unnecessary errors. Let's begin the tensile test.
The load is increasing smoothly, sir.
Keep watching carefully. Every stage is important. The specimen is now in the elastic region.
Does that mean it can return to its original shape?
Exactly. No permanent deformation has occurred yet. Now the specimen has reached the yield point.
So permanent deformation starts from here?
That's correct. This is a very important stage. The material is now in the plastic region.
The extension is increasing much faster now.
Yes, and the deformation will remain even after unloading. Observe the reduction in diameter at the center.
This narrowing is called necking, right, sir?
Exactly. Necking occurs just before fracture. Everyone, please stay behind the safety line.
Yes, sir.
The specimen may fracture at any moment. The specimen has fractured successfully.
It broke exactly at the gauge length.
Excellent observation. Now we'll examine the final results. The test is complete. Always switch off the machine before removing the specimen.
Safety comes before everything else, sir.
Exactly. Good laboratory practice starts with safety. Now measure the final gauge length after fracture.
The specimen has elongated noticeably, sir.
Yes, that increase helps us calculate percentage elongation.
Record the maximum load and the final extension carefully. All the readings have been entered into the observation sheet. Excellent. Accurate observations lead to reliable results.
This is the stress-strain curve generated from our test.
I can clearly identify the elastic and plastic regions.
Very good. Understanding this graph is essential for engineers.
Now calculate the ultimate tensile strength and percentage elongation. We are using the recorded measurements to complete the calculations. Correct. Engineering decisions depend on these values.
These material properties help engineers design safe buildings and bridges.
So every structure depends on accurate material testing.
Testing is the foundation of safe engineering. Improper gripping and poor alignment can produce incorrect results.
We'll always check the setup before starting the test.
That's the habit of a responsible engineer. Can anyone summarize today's important test results?
Yield strength, tensile strength, elongation, and ductility.
Excellent! You have understood the experiment well.
Sir, today we learned not only how to use the machine, but also why material testing is so important.
That is exactly the purpose of every engineering laboratory.
Thank you, sir. This was a wonderful learning experience.
You're most welcome. Always remember, accurate testing leads to safe engineering, and I'll see you in the next laboratory session.